Well, good morning, good afternoon, good evening. My name is Elliot Block. I'm the research fellow at Arm & Hammer Animal and Food Production. And it's my pleasure today to introduce Jeff Kearnan, who is going to be speaking to us about cooling applications in dairies. Jeff was born in Massachusetts, moved to California in around grade 7. He graduated Cal Poly at St. Louis Obispo with his bachelor's degree and Virginia Tech with his master's. Jeff then went to the University of Minnesota as a regional dairy specialist. From there, moved on to Monsanto, where he worked in Minnesota and Michigan, and then out in California for about 10 years. Worked for a couple of years for an independent nutritionist in California, and then came to Arm & Hammer and has been with us for 15 years. At least this July, he'll be 15 years. Jeff, as long as I can remember, has always been very much into cooling applications, heat abatement strategies for farms, and has done a lot of work, has been on a lot of farms making recommendations for heat abatement. And with that, I will turn it over to Jeff. And just fair warning, we are recording this webinar. And I believe if you have any questions, please put them in the question box. We'll all be muted during the presentation. And then I'll be, at the end of the presentation, I'll query Jeff for answers on those questions that I receive. So thank you very much. Jeff, it's all yours.
Great. Well, thanks a lot, Elliot. I appreciate everybody being here today. So as we talk about heat abatement today, there's kind of two main areas that I break out the heat abatement to. And for me, that's direct cooling, things that we're going to do to the cow herself that are going to help her either not pick up as much heat load or to let her get rid of more of the heat load that she's carrying. And so that's direct work on the cow. And then also environmental cooling, where we're looking at more, how do we deal with a specific facility, whether it's temperature, humidity, air exchange, and those kind of things. So the two can work together. Certainly from a facility standpoint, a lot of those things are determined as the facilities are built, but there are some things we can also do to improve that as we go. But the main focus today is going to be kind of the direct cooling on the cow herself. So when we talk either about direct cooling of the cow or even the facility, it's kind of important that we realize the different ways that cows exchange heat with the environment. And so these are kind of the four main methods, and certainly some are more effective than others, and that's what we'll talk a little bit about today. But certainly evaporative cooling is one most people are pretty familiar with. We see it directly as the cow pants. She's using evaporative cooling to try to cool herself, bringing that hot air across the aqueous membranes and trying to cool that air off directly herself. She's not very efficient at that. She's also not very efficient at sweating. You don't often see a cow sweating like you might say a horse that you've seen out that's been working hard, because her rate of sweating typically equals the rate of evaporation. So that's not an area where she's very effective either. Convection cooling is movement of air across the animal, and that can be effective if we have a good temperature gradient. So on a typical, just using round numbers, 100-degree cow, we would need something like 70-degree air with a 30-degree temperature gradient to try to really cool her off. And so that's very challenging in most of our facilities to get the air that cool. Radiation, certainly an area we're familiar with. If cows don't have access to shade, they can pick up a lot of heat through direct sun access, and I will address that a little bit. And then the last one is conduction cooling, where we've been seeing certainly some research happening where people are looking at things like water beds to try to transfer heat down, for the cow. It's the same process that she does. You'll watch if you've got wet areas in a pen or something, and cows are heat stressed. They'll often go over and lay down in the wet areas or mud, and they're trying to improve that conduction for themselves to get rid of some heat. So again, I haven't had a lot of information on that where I see it that effective yet, but I do think it's an area that we're working on. So ultimately the heat stress on the cow is just about her heat load being greater than her capacity to lose the heat. So we can either work to lower her heat load, or we can work to improve her capacity to get rid of heat. So that's kind of what the discussion today is all about. So just a little bit of data here up front to kind of get us grounded, and then I got lots of pictures and examples for you. So hopefully that's something that you'll be interested in taking a look at. This is some work done down in Arizona where they really tried to determine where our cows really starting to drop off on performance. And so this was some work done in some thermal chambers and looking at milk on the left axis and temperature humidity index across the bottom. And we'll talk about temperature humidity index here in just a minute. But really, this is how we gauge, what kind of heat stress the cow's exposed to. And you can see here that by the time she gets around 68 THI, temperature humidity index, she's starting to already lose performance. And so when I talk to these researchers and just look at cow physiology, we really want to try to start cooling that cow before she starts dropping off. It's much more challenging to pull her back to her comfort level once she's starting to get exposed to that heat stress. And so the longer we can keep her kind of up on that flat blue line, I'm going to try using my pointer, hopefully you can see it. As long as we can keep her up here longer, that's going to help us. But once she starts getting down here, to try to pull her back up to that is much more challenging. So as I go out and visit with dairymen and talk about THI index in that 65, 66 range where we want to start cooling, that can be a little shocking for some people, not realizing it, that, wow, that seems pretty cool to us as people, right? The other thing I'd mention is that this was done on cows where they looked at greater than 77 pounds of milk. And the thing to realize is that a lot of our dairies have got such high performance now. I mean, high pens, 120, 130, 140 pounds of milk. Those cows are putting off much more heat than a cow that's producing less. So we need to keep that in mind as well as we look at some of our strategies to help her cool off. So the temperature humidity index, most of you have probably seen the graph on the left. And what we have here is just temperature in Fahrenheit going down the left axis, and then across the top in increments of 5, we have humidity. And then you can just take a look and come across, and we've estimated within the different ranges here of what kind of stress threshold the animal's exposed to. So obviously the hotter and the higher humidity we get, the more stress there is on the cow. The main reason I show this is so that you can see from a human standpoint. I have the human heat index here on the right, same Fahrenheit going down the left axis here with increments of 5 of humidity across the top. And you can see that for most humans, we really don't start feeling heat stress until about 80 degrees Fahrenheit and 40% humidity. And the main point of this slide is that when you look at that on the cow graph, she's already potentially lost about 6 pounds of milk. So by the time we're on our facilities and we're feeling like, wow, it's getting a little warm, cows are probably starting to feel it, they've potentially already lost 5 to 6 pounds of milk at that point. So we have to keep in mind as we look at our different strategies that cows are definitely feeling the heat quite a bit different than we are out on the dairy. So there's a lot going on this slide, but I think this is some excellent work. This was done almost 20 years ago now at Kansas State University by the late Dr. John Smith, who did some amazing cooling work. And I just wanted to share this one because I think it tells you a lot about how we need to achieve our cooling on the dairy. So what we have here on the left is this is breaths per minute. So one of the quickest ways for you to just walk your dairy or your clients' dairies and determine, what kind of level of stress are we at from a heat standpoint is how fast are they breathing, right? Are they panting? Obviously, the cow with her mouth open, tongue out, and saliva coming down is very heat stressed. That's a cow that's up here in the 90, 100 plus breaths per minute. We want those cows to be closer down here to that 50 or 60 range. So that's ultimately our goal. In this particular research study, they had groups of cows that were up here definitely exposed to heat and heat stressed. And then we have different treatments that they were given here. And I'm just going to walk through a couple of these. The first one to point out is the top 2 lines here, the red line and the yellow line. And anything with an F next to it means they had fans blowing on them. So that's airflow. And in this case, they had no water. So the other number is a soaker interval. And here we have just all the control cows in red, and then they just had fans blowing on them. And you can see we had a little bit of an impact, but clearly these are still heat stressed cows. And unfortunately, when I go on dairies, I see a lot of situations where people think they're improving their cooling by just adding more and more fans. And there are times when that can improve things, but typically I see a lot of those fans blowing on cows that are just dry. They have no moisture on their skin, and that's convection cooling, right? We talked about convection, and unless this air can be a good 30 degrees cooler than the cow's body, it's not going to be effective. And so blowing hot air on a cow that's not wet, that we haven't done something to get her skin wet, is just not effective. It's not a way that we can really cool cows very well on the dairy. On the flip side, if we take that same scenario with the same airflow, but we add a 5-minute soaker interval, you can see how dramatically we now shift from convection cooling down to evaporative cooling. So the blue line here, where we drop those cows fairly quickly back down to their comfort level, we've now shifted to evaporative cooling. We wet the skin, and the airflow helps her evaporate that, where she can lose quite a bit of heat from her body load. The other thing I like to point out here is that the green line, which is just soakers with no air on the cow, she's just being allowed to evaporate that moisture naturally, can still be very effective at cooling cows off. I call this about 75 to 80% of the same benefit. And so a lot of my focus as I work with dairies is how can we effectively get moisture on the cow, keeping in mind the demands of keeping water use low and just making sure we're protecting the environment and things. But there are ways now that we can do that to really get good coverage on the cow quickly. And we can get about 80% of that cooling benefit just with good soakers. And this is also a benefit to most dairies because it's quite a bit cheaper, lower investment than having to put in a lot of fans. Only until we've achieved the good soakers do I then talk to most clients about now we can take that next step by improving her evaporation rate, by increasing her airflow. And so we're going to talk about that a fair amount today and some of the good ways to do that and some that I think are less effective. But important points here is that convection cooling, just air on the cow, not very effective. Good soakers can be very effective at helping her, basically because she doesn't sweat very well, right? We're just helping her with that approach to be evaporative from her skin. And that is very effective at getting her to cool herself off. So here's just an image showing kind of what that looks like. I realized as I was looking through these, this picture is almost 20 years old now. So we've been doing this for quite a while where we've got it dialed in pretty well. This is a pretty good size soaker line. It's one of the things we'll talk about is carry capacity of lines, but this is a 3-inch soaker line with a 5-foot nozzle spacing. I know the picture makes it look like they're closer, but they're not. But what we're trying to achieve here is just a nice big large water droplet that's uniform across as much of this cow's skin surface as possible. I want to get as much moisture on her so that she can lose heat from as much of her skin surface as possible. And we're able to achieve this now in about 15 to 20 seconds. So these soakers, as you'll see, are kind of instant on, instant off, and it's very low water use relative to what people think. As I've converted some dairies from mister systems as an example, we're typically saving 65 to 70% water by going from misters that are running almost around the clock during the heat to the soaker systems that are on for a very short duration. So you do need a lot of water when they are on, but the total water use actually drops off quite a bit. And so that's an area that I think people are maybe they're used to soakers, I think, that ran too long and used a lot of water, made a mess, and we've kind of come a long way from those systems. So the point is, after say 20 seconds of those running, we should have a very nice slick coat on this animal. You can see we don't have water droplets hanging up in her hair coat where the droplets were too fine. It's a nice big droplet. When it hits her hide, it soaks right to the skin, and that's what we're after, because now this cow can sit here, and you can see there's no fans or anything, but this cow can sit here and evaporate naturally, even if she's in sun exposure like these cows are. And once we lose about 80% of that moisture evaporated and she's losing heat that whole time, then we soak her again. And so I call that the wet dry cycle. We wet her, we dry her off, we wet her, we dry her off. And where fans would come in and be beneficial is when we add fans to this system, she's just able to evaporate that moisture more quickly, right? And it becomes more effective. So if you remember the line graph, that's the blue versus the green line. That would be the difference here. But these cows are still cooling themselves very well. I prefer to see shade over them, but in this case, they don't have it. But this is still a very high performing herd that's able to get a lot of milk even with this type of an approach. So the nozzle that we typically use in California, and you can use anything you'd like as long as we meet some of the criteria, which is a big droplet. We do like nozzle orifices that don't clog very easily, because I know maintenance is always a real challenge in a lot of our dairies. And so these T-Jet nozzles seem to do very well. The other thing that's nice about this system is they can be tapped directly into pipe. So as you can see, and I'll show you that here in a little more detail, but you do not need fittings or anything to mount these. So it's a very quick install, very easy. If you're handy on the dairy and you got your own shop, you can do a lot of this work yourself. And this is a very nice tip. It's a variable flow tip, so if we don't have enough pressure, it is a challenging, and that's one of the problems we see, is that a lot of lines are sized too small, and I'll show you that a little bit as well. But this tip will flare out as it gets enough pressure. These are running at a little over around 30 psi, and you can see the gallons per minute at 1.3 is significant. But remember, we're only running these for 15 to 20 seconds, so the water use is definitely much less than people realize. So if you look at what that nozzle looks like, it's a 4-part system. It's basically got the body. There is a check valve in those, so that's pretty important as you look at how we're installing some of these. We want to make sure that that line is staying full of water and not dripping, where we're getting dripping onto the lockups or anything into the feed manger. We want to try to minimize that. There's a cap that then goes on, and then the tip. And most of the tips now we're doing are a stainless variety, because we're trying to mount the nozzles a little bit lower than we have in the past. And when cows have access to the plastic ones, they can sometimes break them off. So we've just gone to a stainless tip, and they're pretty much indestructible. I will comment, if you have some of these on your dairy and you have dripping problems, springs over time lose some of their tension, right? And so it's important that you take these springs and you do add more tension to them. These are only a 10 psi spring when they're new, and most of our line systems are hopefully running at least at 25, 30, 35 psi, so we've got some capacity there to add tension, and that's just going to help this plunger seal off better. There are different types of plungers out there. The one with the silicone tip, that's kind of a softer tip, seems to be the ones that seal the best, and so I would definitely suggest that if you're going to source any new parts or anything. The last part of making this work for you is that this $10 item right here is just a 1/4-inch drill with a tap built in. And so if you're using galvanized pipe or PVC, and you can just drill those yourself, and they screw right into the pipe. It's a very easy install approach. So as we talk about skin coverage, I also wanted to point out that when we do this right, and hopefully this is showing up on your screen, you can see that these cows have pretty good soaker coverage. These cows, you can see how wet they are. The very back is not wet. The udders are dry, but you can see how the moisture has gotten most of this cow wet. So she is losing, through evaporative cooling, heat off of her skin. But it's important in our systems that we don't get the udders wet. So when you have a large droplet that's very quick on and off, we're able to keep these udders nice and dry. And this will hold true as we talk about holding area cooling as well, and it's even more important in there. But these cows are getting great coverage from a soaker standpoint, and we're able to keep the udder dry. So again, all the systems we're doing now, that's part of our goal. And you can see here, this is actually a 3-inch galvanized line with nozzles at 5-foot spacing, which is pretty much the theme on the nozzle systems we're doing these days. So here's an example of a typical one that we can make some improvements on. So you can see clearly on these jerseys that we're maybe covering at best about 60% of her skin surface. And this is very typical here in California, where we've got a couple things going on here. My point is that when we adjust this system, I've got about another 40% opportunity here that I can have her losing more heat. And so we immediately get a tremendous improvement in the system and its efficiency and how more comfortable that cow's going to be. So I talk about angle and offset. What we need to do on soaker lines that are like this, they've been mounted in a little too far. A lot of that was done because people worried about dripping. But again, if we maintain those tips and we really make sure the springs are nice and tight, we shouldn't have any dripping on that. Also, most of the new systems are not using an angle iron. We're doing galvanized pipe, so they support themselves. But in this case, if we just wanted to make some adjustments on this dairy without a full replacement, we basically need to drop this pipe down and move it as tight as we can, close to the lockups without interfering with the lockups. And that's going to allow us to spin that nozzle more upright so that it's spraying out over the cow and then dropping on her instead of down at an angle like this. And you could kind of see that in that first picture of the cows in the lockups where the droplets were covering her full skin surface. It's because we were able to spray out more in a flatter trajectory. And we also see less drift that way with wind and things into the feed bunk. And so I think you can see it a little better on this slide. So this was this is a 3-inch line installed with the 5-foot nozzle spacings. And you can see we're a little too steep here on the angle. And so you can see how the spray is coming down and we're maybe still getting about half of that cow wet. But when you look over here, what we've done on the front end of this picture is that pipe has now been angled up more. So you can see these nozzles spraying downward versus this nozzle spraying out flatter. And you can see how much here in the front part of this picture, how much better the droplet coverage is. We can still have somebody here working cows with a veterinarian arming the cows or AI technician arming the cows, and they can stay relatively dry, but the cows are still getting nice coverage. And it's really important that as we put these in, we achieve that. And most of the new systems, we can change the angle by a couple degrees by moving that pipe. And every dairy might be a little different based on their line pressure and application, but we should be able to get that where the coverage is doing pretty well to complete the whole cow. So again, 3-inch lines on these. This is almost 1,000-foot run. We can run the 3-inch line carry capacity is pretty tremendous. So we have a lot of flexibility on length of runs with the bigger line and then the 5-foot nozzle spacing. And again, a system that works very well. We've got some folks even, this is a shorter run, so this is just a 2-inch galvanized, but they're even, when we have large support poles in some of our facilities, we really don't have any opportunity here, right, to get it nice and tight. And so I have a few people that are now starting to mount on the back side of the pole. And so that can work great. We just have to be very careful that, again, our check valves are working properly and we're not getting any dripping or running. We want to keep that water directly off the lockups or getting into the feed, right? So, but again, there are some options to make that angle of the nozzle sprayer work pretty well. So just kind of summarize that, right? Big droplets covering most of the cow. We want that nice, quick, slick look within 15 to 20 seconds. If we have a steep angle and we're not getting most of the cow wet, this is just lost opportunity. There's a lot of situation here where we can just get better water coverage on this cow. And in this case, like this particular dairy had a lot of pressure, and it was just they had offset it quite a bit because they were worried about wind drift, which is coming from the right side of this picture. And but they just were overshooting too much of the cow, so it's harder to see on this picture, but most of this cow is pretty dry. So again, we want the large droplets, quick on time, minimize the drift that way, right? So the short on time really does help us keep water on the cow and not in the feed bunk, have the check valves, and then just get as much of that cow wet as possible. So some of the new technologies that are coming, and this may be very good application for especially some of you in parts of the country where pit capacity and things is a pretty major issue with water use. There are now this particular Avsonic unit. They're actually, I believe they're available now. But so this is the same T-jet tip we were just talking about, but in a body unit that has an infrared sensor. So when these are mounted up on the soaker line at the lockups, if there's not a cow present, the nozzle will not kick on. So it has its own valve. And this is a great way because we do get a lot of soakers running when cows aren't necessarily there at the lockups or at the bunk. And so this is a great way to try to save quite a bit of water on the dairy. I do know a lot of the newer dairies are putting kill switches. So as they bring a group of cows out of the pen to go to be milked and they know that's going to be an hour, they have a kill switch at the end of the pen they can hit that will turn that particular soaker off for an hour. So those help as well. But these are much more individualized, realizing because it's new technology, the cost is going to be significantly higher. But if it's really the only way you can cool your cows, I think it's a pretty good investment still. So the other thing is, as you'll see when I talk about some of the holding area cooling, using some sensors to do more zone cooling or quadrant cooling. And again, the technology's come a long way. These are very accurate. It can really determine if there's cows there or not, and then we can have valves either opening or closing based on that information the sensor receives. So, I'll talk about that here in a little bit. So looking at our typical freestall, at least here in the West, you know, how do we take that evaporative cooling that we've been talking about and take it to the next level? And so you can see in this application, we've got fans that have now been added over the beds, and so there's quite a bit to talk about on this slide because there's a lot of different questions that come up. I personally, I see a trend certainly here in the West for people putting in bigger fans that move more air, and then they just need less of them. And certainly in some applications that can be useful, especially if we're trying to move air through a facility. In most of my open sites here in the West, I'm really just looking for airflow on the cow. Again, remember, we're trying to get that next 20% where we move the evaporation rate upward. And so when I have what I call air points or more fans, more frequently down a barn, I just seem to get more uniform airflow on the cow. And so in this case, this fan only has to cover cows through these two sections of stalls or here at the bunk. The other thing is, as I'll show you in the next slide, fans have performance data that'll show you how well the air spreads or throws off of the fan. And so on this particular fan, it does a very good job of spreading out the air as it comes off the blade. And so we actually get very good coverage here at the lockups. And so a lot of the questions I get is, well, why don't you just put the fans at the lockups, right? The challenge for us in the West here is our summers are pretty long. We've already been in the 80 degree temperatures here, but we'll start getting pretty hot in May, and we'll stay hot through late September, early October, and that's a pretty long summer. And if we don't still have cows using beds and lying down, and if I put fans just out here, we're going to get cows standing here because it is much more comfortable. The challenge becomes we seem to blow the feet and legs off of them by the end of the summer, right? And that doesn't do us any good either. And so the scenario that happens here is the cow's getting soaked, she gets comfortable, she's been eating, the air's helping her evaporate. At some point, she goes and lays in the stall. And if you remember, once she's not wet any longer, so 3 to 4 minutes later with the air blowing on her, she's no longer wet. She's actually starting to get hot again, even though that fan is blowing on her. Again, that's the convection cooling. It's just not that effective, right? I think the misconception is that these fans are cooling this cow when she's laying in the bed. And unfortunately, as you see from the data, right, that's just really not happening. It can help with maybe a little bit of temperature change in the barn or keeping humidity down with airflow, but really it's not that direct cooling that I'm after. And so once that cow gets uncomfortable enough, she picks up more heat, eventually she stands up and she comes back and gets soaked again. And so that process of back and forth in the summer, and I'm talking about 100+ degree days, that's really what we're dealing with here in California. And so what I like about having all these fans with different air points is that you'll get some of these cows, you've all seen it, they'll perch in the stall, right? And if you're not familiar with the term, perching is when a cow will get in the stall, typically just with 2 feet, and she won't go all the way in and lay down. She just kind of stands there. Well, if a cow is standing right here and this air is hitting her, air, unfortunately, will hit her and go off to the sides, and now I have dead airspace behind that cow, right? There's just really no way around that. So as long as I have another new air point fairly quickly, I can continue to have better airflow. But if that air is hitting that cow and I have 2 or 3 cows right behind her, then that's dead air that those cows are not exposed to, right? Because it's already hitting the standing cow and getting turned around her. And so when we have bigger fans that are set up at 60, 80, 100 feet, I feel like we create a lot more dead spots on the beds for sure. And it works too out here when cows are just standing up. So again, that's just my approach. It seems to work well as we do these. We have started side mounting these to try to get as much coverage out at the lockups as possible. Installers will prefer to go right over the post, right? Because it's a little more cumbersome to install this way, but we definitely noticed with a 3 or 4 foot shift, much better flow here at the lockups. And that's because as you look at these fans, and every fan that you're working with, this particular one I've got 20+ years experience with, and so I really do like it, and I'll tell you why here in a second. But this is one of those reasons. It has an excellent what we call spread and throw. So I know if I've got 40 feet between my fans, exactly how much air is coming off that blade and where it's hitting in terms of the width of that blade. And so I can really calculate how to set up the facility to get the best return on that airflow in terms of the evaporative cooling benefit. So that particular fan is an Aerotech Apex fan. The only reason I mention it is because, as far as I know, it's very unique in the industry in that it's the only fan I've come across that has a single one-piece cast aluminum blade. And so you can actually take this blade off and run over it with the tractor, and it's that stout. And why that's important is we see a lot of things like pigeons getting pulled through fans, and if you have a typical stamped steel blade that can get out of balance very quickly with any kind of damage to it or even dirt, you'll lose quite a bit of efficiency on that fan, and we just don't see that on this fan. And again, the spread and throw that this airfoil blade puts off has been really useful for us in a freestall setup. And so the last part, at least here in California, it's a very efficient fan. You can look at numbers like CFM per watt use, and we'll get some state rebates sometimes where a $600 fan might have a $300 rebate. So that makes that very attractive from an installation standpoint. You can go to the Best Lab site. And so University of Illinois has a Best Lab site, which is an independent testing. And you'll want to go there and look up fans that you're looking at and just see how they perform. Most of the major companies all send their fans there. And I always say you want to see the specific Best Lab data. You don't want to look at data that's adapted from, because some of that's been adjusted for various reasons. I like to see the actual test data. And so if you're looking at, Schaefer or any other brands, they should be listed on there and you can see how they compare. From an equipment and controller standpoint, most of you, if you're working with dairy clients or have a dairy, you're probably seen the Edstrom, at least here in the West. And actually in my time in Michigan and Minnesota, we see quite a few of these. It's a very solid controller used just to cycle your soakers or your fans on and off. And so you can do quadrants. Most big freestalls are set up in quadrants where they cycle through the 4 areas. Again, the on time should always be what it takes to get your cow nice and soaked slick, but we don't want to keep running water on that cow once she's wet, right? And I see a lot of people run their nozzles for too long. We're actually hindering her evaporation at that point. So we want to make sure we keep that nice and short. And then the off time, again, everybody always wants a number from me, but it's going to vary on your dairy based on how much natural airflow you have, if you have fans, don't have fans, how quickly your system can soak the cows. But your off time should just be about 75–80% of the water being evaporated from the skin, and then we hit her again, that wet dry cycle. The other thing that we've noticed is that a shift to systems that are better able to open our lines and close them quickly. And so a lot of the traditional valves that we've used just aren't able to cycle that quickly. And so then we have challenges getting our short duration. And so we've been using more like a wafer valve approach with electronic actuators. And this system works very well. You don't get that pounding on the line as it opens and closes. And it really, the ones we've had in for a couple of years now really have done well and do a good job of that quick, 15 seconds on and off. So shifting the same concepts, but now let's look at the holding area, right? And some people, wash pen, holding area, prep before the parlor, whatever you call it. I'll just refer to it as a holding area. But if we have the parlor here on the left, this is the large pen where we normally move a full pen of cows in at a time. And so it's very important that this is probably one of the areas I see the most problems with on a dairy, because when cows are packed in tight and we don't have good cooling here, we actually can spike body temperatures pretty quickly. And I get a lot of dairymen talking about how they're not getting cows bred in the summer, when in fact, a lot of times they're actually getting cows bred, but then we're losing those early embryos here to early embryonic death by getting spikes in cow body temperature. And so it's definitely an area that can not only affect cow performance from milk, but also maybe some of the repro hit you take in the summer. We're doing the same concepts here, lots of airflow. The difference between this approach and what we've been talking about is you have to have both here. I can't just add water to the holding area without air, because the cows are packed in so tight, they won't naturally evaporate that moisture on their own. The humidity levels within packed in tight is just too high. So anytime we do the holding area systems, we need to have really good airflow down into the cows, and we need to have good soaker coverage. And so I see a lot of soakers as well that don't get all the cows that are around the edges, or we might have pockets in the middle where cows stay dry. And it only takes 4 or 5 cows in a certain area not getting wet, where you're going to create some problems, right? You're going to get some of those body temperature spikes. And so this system, which I call a grid system, which is pretty basic, right? But it's a great way to get uniform water coverage on all the cows. And again, we're doing this very quickly, 15 to 20 seconds on time, and it keeps the udders nice and dry. And so what that allows us to do is we can keep soaking these cows right up until they load on the platform in the parlor, and the udders are still nice and dry as they walk up onto the platform, which obviously is our goal. And so hopefully I'll show you some pictures of this and you'll get an idea. Oh, one thing I need to point out, we're slowly getting these changed, but for years there was a lot of systems set up where the air was directed depending on the prevailing wind of the dairy, and maybe not so much in some of the Midwest locations, but certainly here in the West and the Southwest, we see that. And I always want the fans to be blowing out away from the parlor. We're concentrating all this cow heat. You know, there's a good way to look at a cow is she's a 1500 watt hair dryer that's constantly putting off heat. And if I've got 200 or 300 cows in this pen, I don't want to take all that hot humid cow heat and move it into my parlor. I want to be blowing that away. And the fans nowadays are so efficient and good that the prevailing wind really doesn't have much of a factor for us. So again, just quickly through this, but it's same things we've been talking about. Large water droplets, it's going to minimize our drift. We want to soak the cow quickly. Uniform coverage, I talk about it should just look like a nice summer rain shower in there, right? Just a quick downpour and then we're done. Check valves, we don't need the dripping, so those lines stay full. Again, very quick on. So once the cow's wet, we need the water off so she can evaporate. But we've got to have high velocity airflow down into the cow, and I'll show you some pictures of what that looks like. Don't ever put the soakers in without the air. So I always stress that because every year I get somebody who does that, and it's definitely a big mistake. Even though we have good cooling there, we want to get the cows through quickly, right? A lot of times the typical answer I get from a dairyman is, oh, it's about an hour, right? About an hour. And when I walk cows and I just follow cows as they leave their pen and they make it into the holding area and they get milk to come back, a lot of times it's much longer, I think, than our dairies realize. And so anything we can do to shorten that, it's going to help that cow, especially in the heat where she's a little more stressed, and also just get her back on her beds and in front of feed right quicker. And so there's a lot of benefits with that. So the nozzle used, I'm going to show you a T-jet example, but if you use something different, the nozzle used and the mounting height is really going to determine the number of nozzles you need for a typical grid. And so the T-jet nozzle that we've found that's been working fairly well is one of the true full cones that I've been able to find. So the importance, again, the uniformity of the water coverage, right? And so a lot of cone nozzles just have uniform coverage around the outer layer. But this particular one, the TG14W, has a nice full cone. Now, we can't use the same body and check valve spring that we use on the lockups, because this does have a spinner in it that creates a lot of tension, and even the high tensile spring check valves will shatter within about 2 weeks. And so we've gone to this side diaphragm check valve, which is very effective. We tried these with cows 20 years ago. It's just that they're not very durable. Cows can break them off if they have access to them. But mounted up above in a holding area, these work great. And so as you'll see from the next one here, it's a very simple system. That's that side diaphragm check valve. There's that nozzle that comes on, and then the cap just holds it in place. So it's just a 3-piece, and they can, again, be drilled because it's just a 1/4-inch tap, right? They can be drilled directly into pipe. There's no fittings needed. And so you can set these grids up very quickly. Most of the grids I'm going to show you today, based on our California dairies, where we're needing about 9 feet to typically clear all of our crowd gate equipment and still stay below our fans, because we're trying to minimize as much water on the motors of fans and things as we can. But most of our systems here are mounted at around 9 feet. And with this nozzle at a 9-foot mount height, there's a nozzle every 7 feet. So this is a 7-foot grid, and it's been very effective at getting the cows uniformly wet. I'm going to show you a video here in a second of it running, but just you can see where just pretty much in this case, we've got 1, 2, 3, 4 lines covering this holding area, and that they're 7 feet apart. So every 7 feet in the grid, there's that soaker that's getting the cows nice and uniformly wet. Nice big droplets, and it's done very quickly. You can see a little better here where I've put some red dots on the pipe where the nozzles are. But again, a pretty straightforward system. Really just trying to get these cows wet quickly. So in this, I have a little video clip here, so hopefully this is going to work okay for you guys to see it with any lag or anything. But what we've done here, just so I can show you what the spray pattern looks like, is I've actually turned the fans off since we don't have any cows in here. And you can get a feel for just how quickly we can wet cows in about a 15-second type scenario. So hopefully we can get this to play. So you can see how much, I mean, we're putting out a tremendous amount of water, right? But it is done on a very short duration. But that big droplet is really what we need to get the cows soaked quickly. And in this system, when we run this for about 15 seconds, even with the fans going, remember when the cows are in there at a 9-foot mound height, right? And I've got roughly a 5-foot cow, that water is only dropping off that nozzle about 4 feet. So here you're seeing it drop all the way to the floor at 9 feet. But when we've only got about a 4-foot gap there, it gets on those cows quickly and we get them soaked very fast. And then having those fans blowing down into the cows help them evaporate even though they're packed in close together. So these systems have been working very well. On some of my dairies that have actually a lot of parlor downtime, they'll actually potentially bring a group in there as well to cool them if they don't have good cooling out in their pens. I don't recommend that, but it is an option, because you can set these cooling systems up very quickly with minimal investment, you know, as compared to having to get all your pens adjusted. So just as you can see, this is one that's been done in galvanized, right? The grid's just laying below the fans at about 9 feet. We have fans in banks. And the main reason I show these pictures is that we really need the fan down into the cows. And so a lot of holding areas that I see, the fan is too upright. And when you stand there, it feels good, right? You're probably perspiring and that air is hitting you and you're like, oh yeah, we got some good cooling going on in here. But what the cow needs is that air down around her when she's packed in tight. So we don't just want to be moving air across her top. We need it down into, and that's why we need more frequent banks of fans. And again, this is that same Aerotech fan. It throws to the sides so well that we get nice uniform coverage when we put them in banks like this. And so again, this is what I would consider kind of my ideal holding area cooling, and we've had good luck with it to this point. So adding in the same system, but now if we look at some of the sensor units that I talked about with you earlier, you can actually now set these up in zones, right? And so this is where those of you that have a lot of water use issues, as that group of cows slowly loads into the parlor, right? And now we have no cows here. With the sensor unit here, this whole zone here will just turn itself off. And then as the cows continue to load in further, and now we just have the last couple loads of cows up here in the front, the next second section will turn off. And so setting up these zones or quadrants can really save quite a bit of money. And the sensor technology has come a long way where they're extremely accurate. And so we're just now starting to see some of these going in, but what I've seen so far, it looks like they're going to be very beneficial for water use and can really help out the dairies, you know, that are challenged with water. Just one quick comment about different types of nozzles. The IWAB nozzle is very popular in the industry, and the IWAB is a great nozzle, right? Seninger makes a great product. It doesn't clog. It's very durable. The challenge for me with the Seninger IWAB nozzle is that they don't uniformly put out water. So if you've ever been around the IWABs, they put out a tremendous amount of water right around the nozzle, but the outer circumference of that spray is not typically as consistent. So in order to get those outer cows wet enough, you need to run the nozzle longer than I would need on the cows closer to the nozzle. And that's by design, because if you're not aware, the IWAB nozzle is designed for pivot irrigation systems. So it's designed to be moving. It's not designed to be stationary. And so in my dairies with the IWABs, what happens is I get cows that are too wet, and that's causing me to get wet udders if they're near the nozzle. And then the cows that are away from the nozzle tend to not get wet enough. And so if I shorten the nozzle duration for the cows right under it, then my cows that are further away just don't get wet enough. So it's a challenging, and I'm really worried about milk quality and things in the summer, and we want to keep that udder dry. And so we've definitely shifted away from the IWAB. At least I have. I know we still have people that are recommending it, but I think there are better options out there for people to put in. So I always get asked about the return lane soakers. I'll say 20 years ago, I really tried to push these, and I'll tell you that now that we've really improved the holding area cooling with the grids and the cooling at the lockups once they're back in the pen, I'm not as much on board of doing the exit lane cooling. If you have a good spot for it and water's not a major issue for you, then I think it can still work because it is effective. But I'm not sure it's as important now as it used to be. A couple of examples here. On the wide lanes, I think they're very challenging. And this is an example of a dairy that their cows would just pile up behind the soakers, because if you've been around cows, right, you know they don't necessarily like their heads or their ears getting wet. And so these cows would just wait and wait and wait until a pusher had to come and force them through. And so I don't want to do anything on the return that hinders my cows getting right back to the pen, right? I want them having access to feed, having access to their beds. And so I'm always concerned on the wide return lanes when we do something like this. On the narrower ones, the flow usually is not an issue. The cows behind will push the cows in the front. One of my ideas, and this is the Edstrom Sense unit here, the Cool Sense that they have, so you can buy these commercially. But what I've seen is if you take a nozzle, and so I just call this like a finger sprayer, you can get the plastic version at Home Depot for $5, where it sprays out like you're going to do your garden. But if you mount those more down here where I have the red arrows, so that they're still covering this cow, but she's able to lift her head up and walk through that without her ears getting wet. What I've noticed is that the cow flow is much better. She can get through, keep her head dry, but the rest of her body gets pretty good coverage. We want to be sure we're not getting any water on the udder, obviously, right, to be washing off any teat dip. But that system can work. I think it takes a little bit of fine tuning, but as long as you got a narrow area like this, I think it can work. We obviously want to set that up on some type of wand or I-beam sensor. And I have seen cows that learn how to trigger it and then they run through it after it's off. So you do get a little bit of that, but having those run all the time is definitely a water use that we probably don't want to have to deal with in terms of excess water. So just a quick summary. Again, maximize evaporation rate. Everything we do is about getting that cow surface quickly with large droplets, lots of exposure, more cooling, increase that rate with more airflow. And that can be natural or mechanical, especially in the holding area. And that does also help us lower humidity, and that affects our THI index. And then we just want to get as many of those wet-dry cycles per hour as possible, and you're going to see really comfortable cows. And so we're doing that. Again, the large droplets. The line pressure can definitely be an issue. If you noticed on like a 2-inch line, trying to run too far in a freestall, we just don't get the nozzles opening up all the way to get good coverage. And so I see a lot of dairies trying to run like a 2-inch line 400, 500, 600, 700 feet, and that just doesn't work. You can't overcompensate that with pressure because those are variable flow tips. So as you add more pressure, the tip just puts out more water. So the carry capacity becomes a challenge. So I want to try to stay over 2 inches, and I've just kind of put in around 300 feet. I've seen some people with 300-foot runs that can make a 2-inch line work, but after that, I think for the cost difference, and it's something you're living with for 15 to 20 years, you should just go the extra route and put in either 2.5 or 3-inch line, depending on how long your run's going to be. The green tip T-jet nozzles work really well, and then again, make sure those check valves are working instant on, instant off. I will mention when I showed you the Edstrom, I always get questions about where do I put my sensor, right? And so that is a challenge. I think every dairy needs to gauge on their own, like at the beginning of the season, okay, is my sensor in a good spot where it's really actually, getting an accurate reading? We don't have sensors that really go in with their cow level, right? So normally we're not estimating enough how soon we need to get the systems on. And so I think you just had to go out there on your own and look at it and say, okay, I maybe have it set at 70, but those cows are clearly hotter than that in the pen because my sensor is, 8 feet above them up in the rafters. And so those are some things that each dairy just has to consider on their own. So enclosed facilities, again, I'm not going to talk a lot about enclosed facilities. A lot of the concepts we've already talked about obviously can work within our enclosed facilities as well, but most of these barns, so big cross vent barns, tunnel barns, anything where we're moving a lot of air and we've got an enclosed facility, most of those have hopefully been designed properly when they've been built, because it's very hard to change them after the fact, right? So my only point when I deal with facilities like this is just make sure, you know, we're keeping up on maintenance, the fans, the, you know, belt tightness, or, you know, keeping things clean. If we got direct drive units, whatever it takes, those fans are designed to operate, you know, at an optimum level to make your facility work like it's supposed to. So that stuff is pretty important. Obviously, we're regulating temperature and humidity as we move air through the facility, and then airflow on the cows, right? Most of you have probably seen, but a lot of our barns like this have the baffles that come down and try to keep the air down on the cow. There's some good videos out there where we, you know, run smoke in these barns, and you can see how the air drops down on the cows. I didn't put one in today, but you can certainly go out and find those on YouTube. And again, it's just about trying to keep the temperature as low as we can in those facilities. I do think that's a little more challenging. We have different ways that people are overcoming that. And this facility is a great example. A nice big barn where you can see the fans at the other end. We're pulling air down through. I'm actually taking this picture standing in front of evaporative pads, and so they're cooling the air as it comes into this facility. Plus, they're adding a high pressure fogger system. And so the air is very comfortable in this barn, and the cows are very comfortable. And so in this particular situation where they have some water limitation uses, this is the best way they can keep their cows cool. And if most of you aren't familiar with barns like this, I always find it interesting as I talk to people. So 20 years ago, as we were doing tunnel barns in Minnesota, for instance, where we had old sites and we're trying to get more air on the cows, and we were setting up tunnel systems, you just need to know the cross diameter of this barn, right? So it's the width and the height, and you can run the calculations for how much air you need. The length of the barn really is not a factor, right? Not for how much air capacity you need. So where it's a situation that's a problem is that if you're trying to move too much air through this barn, as the air travels towards the fans, right, it's picking up cow humidity, it's picking up cow heat. And so the biggest limitation on how long we make these barns is, what's the air look like when it gets to the other end of the barn, right? Are those cows still comfortable? We can overcome some of that with more velocity, right? We just move more and more air through the barn, but there are limits to that. And so otherwise, you know, you can have a barn that's 300 feet long or 3,000 feet long, and you'll need the same capacity of fans at the end and the same inlet size on this end to make that work. It's just a matter of how do we keep the air temperature and humidity at a manageable level after it travels over so many cows. So if you're not familiar with these barns, it's a very interesting concept of how we build them. So I want to talk about water because I think it's one of the quickest ways we can improve some of our dairies for summer performance. And everybody thinks they have enough water, but I'm gonna challenge you that you don't. And I'm gonna jump into it pretty quick here because let me see my timer here. Okay. So I would mention that water trough access is definitely important, obviously, and there's some numbers out there that talk about linear inches per cow and things. I definitely think I see situations on dairies where we have problems, whether fill rate, right? Our lines just can't keep up in the summer to demand. You know, as your cows are drinking 30% more water, right, your total demand really goes up. And then I see situations like this, right? This is an impressive clean cement water trough. The challenge is when you walk up to this trough, it smells like a pool. And so the chlorine used to clean this is a problem in my mind. I just prefer a brush and some elbow grease. And I see a lot of dairies that over-chlorinate to try to keep their troughs clean. And we do want them clean, but I think we know how sensitive the cow's nose is. I mean, she doesn't like these full of grime, but she also doesn't really like the chlorine either. So anything we do to limit water intake is a challenge. The other thing I'd throw out for the summer is that when we have troughs that are like V-shaped, and this one's not, it's a little V-shaped, but not as much as some, I see a lot of floats that are set 3-4 inches below the top capacity of the trough. And I know people do that often in the winter because they worry about splashing and cows making a mess. But I would challenge in the summer, you want to get all your floats set to really use the full trough capacity so that as you get 3, 4, or 5 cows come up to this trough and they drink it down, you're typically going to have cows waiting for it to refill, right? And so the more capacity that trough can hold initially, the better you're going to be able to meet the needs of the cow as she drinks. So just a small thing that can be fixed each summer. Make sure all the floats are set properly and really get full capacity out of those troughs. So this is the main thing that I get excited about on the water side. This is some work that we did 20 years ago now, and we've put a lot of these in since then. And I really think from a return on investment standpoint, if you don't have good water access on your return lane, I think this is one of the best things you could go out and do even right now before summer hits, because you can put these in pretty quick. And it's really amazing how many cows will utilize this and really drink more than you expect. And so this is, I size these typically to the number of cows that are coming off your parlor return. And I like to have a minimum of 2 linear feet per cow, right? So in a double 30 scenario, you know, I've got at least 60 feet. And I say that's the minimum. If you have the area to do more, I believe when we did this one, this is an 80-foot length. And what we like is having this all continuous, right? So now the social issues within the Pentacows, the dominant cows, the subordinate cows, everybody's got the ability to access this. When you watch return lanes where there's only one trough that's 10 or 20 feet, you'll see one or two cows can dominate that, and you'll see a lot of cows won't challenge them, right, for trough space. And we definitely know that's the social interaction of the group. But when you have a long linear run like this, it seems like we get much better usage, over 90%. One last thing before I move on with this is that when you do build these, you want to make sure you have a nice large basically way to get the water out at the end. And so when you pop the cap on the end of this particular one, the siphon effect of this pipe draining the water really cleans it out as well. So this stays extremely clean. And that's one of the key points of building these, is that I want the water here to be crystal clear, and the PVC obviously is not going to pick up any flavor like we would have with concrete and things. And I personally, I don't have data on this, just anecdotal stuff over 20 years, but it seems to me like we get a lot better usage out of these. I don't know if it's the light reflectance off the PVC, if it's the fact that the flavor stays consistent and we don't get a lot of dirt in there. But you can see here, even with me taking this picture, as these cows were going back to their freestall, we get a very high percentage would index in and just really drink out of this. This dairy was using like a 2-inch high capacity line to keep this thing full between groups of cows. Very tremendous opportunity. We know that cows physiologically are very thirsty, right? We take all that milk off of them as we milk them, and we know how thirsty she is, right? It's like an athlete that just got out working out, they're thirsty. So if we can take advantage of that and really let these cows tank up on water as they're coming back to the barn, we also know that water intake is going to help drive appetite. So now the added benefit is she's going to go back and stand up and eat. And that's going to also allow our teat sphincters to close up more, right? So instead of her being tired and going back and just laying down, she drinks all this water that helps drive some appetite. She's more likely to go back and stand and eat, as long as hopefully we have fresh feed waiting for her. And I think there's a multiple benefits there that these can generate. And so we've put a lot of these in now over the years. I always get questions about durability. I use this one as a good example. This one's been in over 15 years. Cows actually can bump up right against it. And we've never had any issues with breakage on ones that are set up like this. I do recommend that we maintain part of the pipe intact, right? So we just have sections cut out, and by keeping part of the pipe intact, it stays nice and rigid. And this is pretty thick wall pipe, obviously. I always suggest that you just price with your local supplier if they have any large diameter pipe left around from a job or something, 18, 20, 22 inch. It's kind of whatever can work in your setup. It's not cheaper necessarily than concrete, because the end caps are very expensive. So just to give you a warning, it's really more to me about cow access and cleanliness of the water. And whatever it is, if it's, like I said, the reflectance or whatever, we just seem to have a lot of cows use these. And they've been a tremendous benefit. I've had dairies that have put single units in like this and just want to see, what kind of access the cows are going to have to it. And then before long, we're putting them in. This particular dairy has them all over their travel lanes. The other question I get is, I don't want my cows slowing down as we load them into the parlor. But what we see is that when you're taking a group of cows to the parlor, they're usually very focused on, getting the pressure off the udder. And we don't normally see a lot of cows stop and drink then. But as they come out and return, again, if we have enough access along linearly for the cow, we seem to have really high percentage of those cows will go ahead and go in there and drink up. That takes a lot of pressure off your pen, right? So that if you do have some problems in your pens, or if you're expecting cows to walk, a couple hundred feet to use another trough, you're not asking them to do that now. You're letting them go right to the bunk and start eating. So I will mention, don't do this where we just put too small of a valve in here, and so that just doesn't achieve the same thing of really cleaning this out each time. So just more of a little heads up there, but lots of options. The other thing is, if you have rubber in your lanes, it's good to rubber over to the trough so that they don't just stay on that rubber focused, right? We know how much cows like walking on the rubber, and if you got like an 18-inch strip they're traveling on, they may not go off as frequently as we'd like to use the water. I see that varies by dairy. So, and then here's one. Just went in this summer. This dairyman tried to get 2 out of 1, right? So I was wondering, it was holding up pretty well, and so this is the first one we've actually had break. A cow did hit it just right. So I do feel like, unless you have some really thick-walled stuff, you maybe have to keep part of the pipe intact. But this dairyman was very impressed with the amount of usage that cows were getting at it. This one's mounted a little high. One of the things I evaluate on the dairies is just, are we too high on some of our troughs? I think cows prefer to have more of a downward angle where they can also exit quickly if they get spooked. That's part of that whole flight or fright thing. And I think this is a little too high. The dairyman commented, yeah, they sized it more for the pen than they did the lane. And so they were talking about on the new ones they put in to drop them even lower. But just a great use, I think, application. Cows will stop and use these things. So just wrapping up, just some of the watch outs that I see that you may have to want to check your dairy on. A lot of undersized lines, like I mentioned. And I'll tell you, you may think you have a 2-inch line, but this is a dairy example where we just weren't getting the pressure on a particular barn. And when we tracked it all back, it turns out at some point when work was done on this, somebody, maintenance or whoever it was, we have a 2-inch line coming out, but then it goes 1 inch and then it comes back to 2-inch, right? And I think we all know that doesn't work very well. Also from an airflow standpoint, I've got situations here where I've got a fan blowing one direction and a fan blowing the other in a holding area. So these cows really are limited to airflow, and I really prefer the air goes one direction. And so there's some cases like that that I try to point out, to different sites and facilities. And then obviously here, like full sun exposure, we didn't talk about radiant heat too much, but the amount of heat the cow picks up when she's out in the full sun is just tremendous, right? So we want to try to really minimize this and at least get some shade cloth or something over cows like that. So that kind of wraps up more the direct cow cooling and what we can do to help her. I've just got a couple quick slides on some nutritional considerations you may want to look at for the summer. Most of you, if you've got clients or you're working with nutritionists, are probably making changes as you head into summer. We do want to talk about, making sure you do that early enough, right? Don't wait for the heat to hit. Start making some of those changes ahead of time. Focus on, the cow's needs in terms of the amounts that she needs, not necessarily percentages, and realize that she's going to be losing more, minerals and things from sweat and saliva and urine in the summer than she typically does. And most of the new software programs like NDS, AMTS, they all can help account for that as long as you're changing the environmental factors for the site. And so just something to keep in mind as you make those adjustments. The potassium loss is just tremendous in the summertime. Research will show up to a 5-fold increase in potassium loss just through the sweating. And also, we often forget, we talk about calcium all the time, but milk has a huge amount of potassium in it. And so as cows still continue to milk for us in the summer and they eat less, we just tend to see more negative potassium balance through the summer months. So something to keep in mind. The other thing is as cows respirate more often or pant, even if you're not necessarily see them panting, you'll notice that they are breathing heavier, right, as the heat increases, and they tend to blow off more carbon dioxide during that respiration process, which impacts their blood buffering capacity. So we have to worry about that, and we can increase buffers in the summer, typically with a sodium or potassium-based buffer, and that can be very effective and really a pretty low-cost kind of a fix to solve that problem for the summer. And then also you'll hear a lot about heat generation and changing diets for generating less heat, and you can definitely feed more efficiency energy sources to help contribute less heat, and realizing that cow's going to be eating a smaller package in the summer just because of the stress level she's dealing with. So our suggestions in that would be, from the potassium standpoint, We like to look at 1.8. I even have some dairies that do 1.9% using, we have our DCAD Plus potassium carbonate, which we think is an excellent option to help get the potassium levels up in the diet. Just keep in mind as you make those changes that you want to keep your potassium to magnesium ratio somewhere in that 5-to-1 or 4-to-1 on a dry matter basis. And that's something that can get out of whack pretty quickly on some of these diets. So you want to definitely watch that, and typically may have to add some mag back in. Also, we can look at the buffer intake, right? Hopefully most of you are feeding some type of buffer at this point, but there's usually some room to add more there, certainly in the summer, anywhere from half a pound or up to a full pound of, in our case, we have SQA10 or our sodium bicarbonate buffer that we sell. Both of those are excellent options for buffering your cows. And I have plenty of dairies that'll feed a full pound. Certainly in the summertime, they can take advantage of that. So when you kind of optimize your buffer usage there, hopefully with SQA10 or our sodium bicarb, and then make adjustments for potassium level using our DCAD Plus, now you've able to hopefully get your diets upwards to that 35 or 45 DCAD level. And I'm sure most of you are familiar with that number, but it's just the DCAD equation, right? Looking at your sodium and potassium positive anions versus the chlorides and sulfur, right? So again, number to keep in mind, a lot of base diets, if we don't make these adjustments, are more in the low to mid 20s. And so there's definitely some room there, and with proven performance, certainly through the summer months. And then lastly, on the energy density of the diets, right? We have our Megalac product, which most of you hopefully are familiar with, or our Essentium, which is Megalac with the omega-3s and 6s, both excellent choices for energy density in your diet. Having smaller package that the cow's eating in the summer, but we can still maintain performance. And that at a half a pound to 3/4 of a pound is a great investment year round, actually, but especially in the summer where the cows are tend to eat less. So last summary slide, just went through a lot of stuff here for you, but hopefully you get something out of it. Again, don't hesitate to give me a call, send me an email. I'll send you the presentation, or I can answer some individual questions as well if they don't get addressed here. But heat abatement, right? It's all about making sure cows got shade. This water and the soaking and air movement help drive that evaporation. We want to maximize the skin coverage, get more of that wet, dry cycles per hour. The water access, I went through that really quick, but if you do anything to your facility this summer, boy, add more return lane water. Hopefully you got a good spot for it, and you'll be impressed. I would challenge you that easily those are paid for within the first 30 days. And often I have guys tell me they think it pays for itself within a week or two. So those systems really do work pretty well. In 20 plus years of recommending those, I haven't had anybody come back to me and say it was a mistake putting those in. And if you're a dairyman or work around dairymen, not having anybody tell me it was wrong has been pretty good. So those are really a good investment. And then again, for the nutrition, smaller package the cows can eat in the summer and make sure we keep the energy up. Megalac or Essentium, our buffers, and then also DCAD with our DCAD Plus product really can help keep your performance rolling in the summer months. So we want to minimize the heat gain that the cow picks up, right? And we want to maximize her loss. And if you just keep that in mind as you make changes on your facility, hopefully you'll be successful in keeping those cows cool in the summer. So appreciate everybody's time today. And I think there's some questions that Elliot may have for me here, but feel free. I mean, that's my cell number right there. I do answer it. If I don't answer, leave me a message. I do get back to everybody. And that's my email. So if you do want a copy of this presentation as a PDF, I'm more than happy to send that to you. Or if you have other questions, even if you've got a dairy, somewhere that I don't frequent, you can always shoot me some pictures if you got questions about certain things. I'm more than happy to try to help you there. And even if you're hearing this on the YouTube recording and you kind of missed the initial presentation here, you can still reach out to me. It's not a problem at all. I'll try to work with anybody that wants some help around the cooling. So again, appreciate the time today. Thank you very much.
Thank you, Jeff. That was really great. I'm glad you mentioned something about nutrition, or you wouldn't make it to 18 years here, I don't think. There are a couple of questions here that I'm going to pose to you. One thing I'm going to talk to you about, though, is I've been around the world in dairies, especially in some hot areas of the world, that they seem to be high use of these foggers that are mounted on these ceiling fans. And I know that it cools the air, the fogging cools the air, but I don't find the cows to get cool at all. And in fact, I find them to be heating the cows up because the hair gets wet, but the skin never does. Do you have any comments on those?
Yeah, no, that's a great point, and I certainly deal a lot of there's different terminology, right? Misters, foggers, any of the small droplet type systems. The challenge is always maintenance, right? So if you truly have a fogger or a mister that's working like it's supposed to, you should be able to put your hand 2 feet in front of that tip and it should not get wet, right? The idea behind those systems is we're going to atomize moisture into the air and we're cooling the air. The problem is those tips, right? They clog quickly, mineral deposits, and now they'll spit. And if you're getting the small droplets in the hair coat, we actually do see cows heat up. I've got some great slides. I wasn't able to share them today, where actually the small droplets on the hair can actually trap heat between the hair coat and the hide, and that can become a real problem. So that's why we talk about soaking, right? The big droplet really get to the hide. And I think a lot of the fogger and mister systems, if somebody says, boy, we just can't use soakers because of water, we really got to make sure the maintenance on those stays high. And it's still challenging to get the air cool enough, right, to get our cows comfortable. I tried to show that, dropping air temperature, 30 plus degrees is pretty tough. And so, I know it's a water use situation for a lot of people, but you'd be surprised. Like I said, certainly some mister systems here in the West, as we've swapped out. I just had one 2 weeks ago. We cut their water use 69%. So just because the soaker uses a lot of water when it's on doesn't mean it uses a lot of water throughout the whole day.
Thanks. So a couple of questions that I have here from the audience. What are some of your thoughts on dry cow cooling? I know there's been some work that's been recently reported. I don't know if you have any thoughts on that.
Yeah, you bet. I didn't really have time today, as I noticed now looking at my clock, I went a little over, so I apologize to everybody. But I get excited about this topic, right? So I like to really get into it. But yeah, the dry cow cooling is critical, right? The University of Florida has now published the full papers on that. 9 years worth of data where we're looking at not only cooling the dry cows, but what happens to that cow's performance, her baby, the embryo that gets heat stress during that dry period, how they perform then as milking animals, and then also their babies perform, right? So it's a tremendous data set. I've summarized most of that into a one-page summary. It is a lot of data, but if anybody's interested in that, I could send you the one-page summary. The full papers they were published in 2020 with Jeff Dahl's group. So it's if you just type in DAHL and Google that with dry cow cooling, you'll probably be able to find most of that information out there. But like I said, I have a one-page summary on that, but we definitely have really focused hard here in the last couple of years of getting dry cows cooled. Even if it's just a matter of getting some good soakers on those cows, it really makes a huge amount of difference. And so, especially if you're spending a lot of money on your genetics and you're really wanting to get, those genetics performing the best they can, I don't think we ever realized that our facilities could impact that, right? Not only for that animal, but her offspring, right? And so, it's important, I think, that we get all that dialed in, and it's so low cost to get some of that cooling in place relative to everything else we're investing in. So definitely need some dry cow cooling, and I'll happy to share that data with anybody that wants to see that one-page summary.
All right, thanks. Another question here has to do with drift on using soakers and getting the feed wet in the feed bunks. Is there a way to control that, or how do you control that?
Yeah, so I think a couple things we've done, right? By shortening the on time, we definitely have reduced the amount of drift just by the nozzle running for less time. I've had plenty of dairies that were running a minute plus, 2 minutes, and when we've now dropped that down to 15 or 20 seconds, we just naturally reduced the drift. Also, as we lower the soaker, the nozzles, because we change the angle and they're shooting out more onto the cow and dropping on her, even if we have some direct airflow hitting that, it seems like we don't get as much pushback into the feed bunk as we used to get when the nozzle was more at a downward angle. And so I think those combinations, and if somebody really is worried about that or worried about water use, then the new sensor units could really help that, right? So a lot of the drift happens when there's nobody at the bunk and those nozzles come on. And if we've got some breeze blowing, right, the water's got a lot further to travel before it stops on something, in this case, the floor or the lane. And so if the cow's there, then that's not a big deal. It's a foot or two and it's on the cow. But when there's no cows there, we get some of that drift, and having the sensor units in place that don't come on without a cow there would definitely help that.
Thanks. And the last question that I have here has to do with nozzles getting clogged with sand in certain areas. So how do the nozzles you're recommending handle these sand cloggings?
Yeah, for sure. Nozzles getting clogged or basically just having problems is a huge issue. Maintenance, ongoing maintenance on a dairy is always a challenge. The T-Jet nozzle, particularly the green tip, has done really well, even in my dairies that have a lot of sand. I've had dairies go to some different T-Jet tips because they're worried about water use. And as you drop down in orifice size right on the tip, you definitely can have more issues. So if you're good with using the green one, which is the one we recommend, I get very few comments that we ever have any cloggage. The nice thing is they can also easily just be popped off and unclogged very quickly, right? It's not a major issue. So very easy to manage that. And yeah, no, I think as far as all the different tips I've seen, they're probably one of the better ones for not getting clogged up.
Okay, let me see. I think I have one question here. Oh, this sounds like a planted question, but it isn't. What is there a role for Amex or yeast cultures in reducing heat stress?
Well, I got the expert here that's facilitating, so you go ahead and give your spiel.
No, but that's kind of yes, yeast cultures, Amex specifically, we do have some research that shows that it reduces some of the effects of heat stress. It does improve the situation. However, I would definitely say, and I think anybody out there would agree, that it's the first thing you have to do with heat abatement is facilities. And while you can achieve better results with some of these nutritional interventions, including yeast culture, your first dollar should probably be spent on heat abatement and water and fans.
Yeah, one of my California dairies, they did some work with UC Davis a few years back with our Amex product, and yeah, if I remember right, it's like 2.6 pounds of milk, and so that's on a commercial California dairy in the summer. So I'm pretty happy with those.
Commercial California during the summer that had some heat abatement strategies in place. I don't know exactly what they were, but I know they had some. Are there, I don't see any other questions here. Let me, oh, wait a minute, there are some. They're not opened up. Any thoughts on cooling a grazing system where milking shed does not have a roof? Any benefit to water use in those situations?
Well, I think definitely, we can always cool the cow better, if we can shift over to evaporative, but I don't have a lot of experience on the grazing side. I mean, I do have some beef background, so cow-calf operations, grazing, right? So I can kind of relate from that side of things. But my concern would be, what are we going to create a situation where the cows are going to hang out there and not be out eating like they should be? Are we going to create, mud problems, those kind of things? And so hopefully, we've got some good shade access for those animals during the heat of the day, and they're out grazing when they're supposed to be. I don't know how we'd be able to really incorporate soakers in that scenario. If you're telling me there's really no like covered area where they come in to be milked at. So that'd probably be a case by case type thing, but that might be a challenging one to make work effectively without creating more problems.
Okay, thanks. I'm trying to see all of these. I do have another question here. Could you please tell me the use of betaine in summer heat stress and the dosages. I don't know if, Jeff, you have anything there, but betaine is basically a source of methyl groups, just as an answer. So it is something you can use instead of choline. My personal recommendation has been to use the rumen protected cholines rather than betaine, because betaine can be used up in the rumen and not wind up with effective transfer to the cow's metabolism. I don't know if you have any.
Nope,
Jeff, if you have anything.
No experience with that one, so it's a good thing you're here facilitating.
Here's one more. Okay, I have to translate this. What's the difference in water usage, especially corrals? I'm gonna mess this up.
Yeah, if there's
Have any
questions,
recommendations on corrals on open lots? I think that's what this question is getting to.
Yeah, I mean, so I have a lot of open lots, obviously, in California still, right? We just call them big dry lots, right? But open lots. I will tell you, I've had some people make some pretty big mistakes by putting fans under their shades out in their lots, and then they suddenly realize that in the real hot summer months we have here, cows won't go under there, and that's a great example of the convection cooling going the opposite direction. So most of you have probably seen convection ovens now that are pretty popular in your kitchen, where you're just using hot air, right, to cook items. Well, sadly, you know, when we're 100+ degrees and we've got that hot air under a shade blowing on cows, it's actually heating them up. And so that's a case where, you know, typically in our lots, we can't add water. So we have water at the lockups usually. And here in the West, we have a lot of flush systems, so the water use is not a problem. But I do have some guys that don't even have flush systems, that because we can keep the nozzles on such a short amount of time, they still run them. And the big problem, if you remember the freestall discussion, we're going from the lockup soaker to the bed and back again as they pick up heat. In our big dry lots, right, if the cows are out under the shade, that's a much longer walk. It's much more challenging for them to go back and forth to get cooled. And so that's where I think in the summer months, right, our dry lots tend to take more of a hit on the heat stress than our freestalls do, certainly here in the West. Yeah, on some of these questions, if they're really not getting to what you wanted, feel free to email me, and I'll try to address them that way as well, right? If I maybe missed the boat on that one for what you were looking for, but
yeah, please feel free. There's also some questions about soaker nozzles in the feed alley, and I think you addressed some of that. Person can email if it hasn't been answered. There's also a few questions on Amex or yeast culture versus other products. And as much as I'd love to be able to say that Amex is best, I can't, because we don't have any head-to-head trials, really. We only have trials done on our product. So I have to leave it at that. If there are any other questions, please feel free to contact either Jeff directly, or if you want to send the questions to me and I'll send them to Jeff, that's fine as well. And in the meantime, I want to thank everybody for their time. We went a little bit over, but I think it was worthwhile. And thank you very much, Jeff, for your time on this.
Yep, thanks everybody. Appreciate it. And don't hesitate to reach out if you need some help.
Thank you all. Goodbye.